Hi, all of you. Good afternoon. Audible to all? Pooja, Arbaz, Arshdeep. Okay. Hello, Nayan. Good afternoon. Good afternoon, Preeti, Anuksha. Nayan, yes, there is some corrections done. Give us some time. Meanwhile, use the browser, please. Okay? We will rectify that. We do have an issue there. Okay, fine. So we have started with geomorphology. And before we start off, two things. One is the older students, if you have done the assignments that we had told you, one was submission on the settlement geography ka synopsis. How many of you are doing that? Raise your hand. Okay, some of you have done that. Very nice. And the second is the submission of any other previous NCERT work. Okay, we had asked you to do the NCERTs of polity, of economy, of geography. Okay, please submit all of that. And yesterday we added the next NCERT. The new students also will be part of that. Okay, Aniket, I will look into that. So you do your work. Okay, we will let you know on that. So the next NCERT you're doing is class 11th NCERT, which is on macroeconomics. And before the older students have done the class 11th economy, which is about India and development. There are two of them. This is done by the older ones. So if you can move faster, you also can finish off both. I'm trying to keep all of you at the same pace eventually. Okay, so slowly by the end of a month or two, along with the class pace, you would have done all the important NCERTs. They'll give you a good base. Okay, so do all of this work. And the submission for this, I said, is what, Thursday, I believe? Friday. Okay, fine. You bargain. Okay, I thought it was Thursday. The next Friday. What day is that? Date batao mujhe. 16th hai. 16th, 15th, what is it? It is 16th. 16th Feb. Okay, Pooja, तो बाकी submissions भी कर लेना. Okay, so we'll mix some economy, sometimes history. And the last assignment I gave the old students was to finish off the themes in history, 1 and 2. Okay, how many of you will submit today? Anybody is ready for that? You will submit? Okay, fine. Online, you have your tabs ready, please submit. Agar nahi hai active, I'll ask them to activate that. Okay, so please maintain the pace. Okay, excellent, Ellen. Only one book, do the rest, Aniket. Okay, now go with this schedule. ठीक है, कोई बात नहीं. Okay, and on a daily basis, okay, on the daily basis, we want your class synopsis also submitted. Today afternoon, we have an activity session, and based on the performance of the previous assignments, I read out the names, and some of you will be allowed into it, not all of you. I had read the names out last time. So 3 o'clock, those guys can come back and join us. The new students, I'll let you know when you can join. So base bana lo pehle. And it's not that like I said, I'm not punishing the others. The idea is I have to incentivize those who are working. And only when you're working, see what happens is, ek hai, one is your core concepts. And core ke baad mein, there are certain additional work. Okay, your additional work will make no sense if the core is weak. Example bolte na, for example, you have gone to restaurant to eat, have a good meal with your friends. The core is the food that they serve. Aapne order kiya hai, the core. The additional is maybe they have music going on. Additional is maybe a free starter. The additional could be some other incentives in terms of maybe coupon and cards. So all the additional is of no consequence if the core is not strong. And for you, the core is your daily class. The core is your NCERT works, and whatever reference readings we give you. इसको नहीं करके आप यहाँ आओगे, कोई फायदा नहीं है. So the new students, let us do this first. Get the habit of daily synopsis writing, a daily work of NCERT, and then we'll let you know when you can start attending this. Okay, so let's maintain a process on this. Okay, fine, Komal. That's perfectly fine. No issues. Okay? So that was a reminder for all of you to get ready for the next submissions. Let's get back with our geomorphology now. So in geomorphology, yesterday we discussed what is the structure of geomorphology as a unit. Okay, we have tectonic geomorphology, we have the structural geomorphology, and we have the applied ones. Okay, and thereafter we moved into the first discussion was the interiors of the earth. Interiors of earth, I said it is layered. It is layered because of the nebular accretion process. Okay, it is a process called as gravity collapse. The process of gravity collapse. There is density differentiation. ये words important हैं. There is differentiation of rocks and minerals. We also have composition differentiation. Right, so Earth's interiors is not one solid rock, layers हैं. Now, about the conditions, we had one discussion on, a quick one on, how does the pressure and or how does the density change? Density change. The superficial layers, they have 2.5. The oceans have 3.5. The upper mantle has 4 to 5. The inner mantle has about 9. And by the time I hit the outer core, it's 11. The inner core is 13.5. So it is increasing, and on an average, the Earth's density is 5.5. Okay, fine, Pravash. Jitna kar paate ho karo. No problem. And yes, you're right. Dekho, is asking me, sir, is it not enough to just mention the density is increasing? Should we remember all the values or not? See, this is one of the wrong notions we have about our study. Knowing the concepts is very important. The concept is Earth is layered. The concept is the density increases as I go down. The concept is, it is because of nebular accretion. But if you just say this much, you don't have the depth in terms of establishing it. So if you say nebular accretion, you add the name Laplace. Nebular accretion, the word called gravity collapse. Nebular accretion, okay, how a cloud differentiates. ये जो detailing है ना, the detailing is what gives me confidence you know the subject. Okay, so concepts are very important, but the concepts have to be substantiated. So कल interview में, okay, I was asking somebody, I asked him कि tell us, why do you think India is capable of, if you think India is capable of overdoing China as an economy? I said, पहले बताओ कि हो सकता है कि नहीं? He said, हाँ हो सकता है. I said, why do you say so? So tell me first, what is the size of Chinese economy? There are 14, 15, 16 trillion dollars, whatever. India का size क्या है? About 3 trillion dollars. So how do you say इतना बड़ा gap bridge हो जाएगा? If India is increasing, China is also increasing. Then he made a good discussion. He said, sir, China's increase, if you track, it started from 1980s onwards. And by the end of 1990s, China was a massive power. And the growth in the GDP size was approximately more than 20 times. In case of India, and the 20 times was possible because of globalization. आज के condition में, the globalization has slowed down. It's not that कि China will keep on growing at the same rate. Then I asked him, तो फिर India का भी problem होगा? He says, no, India में difference है, sir. Indian growth rate will be buoyed by our domestic consumption also. So while the global might not grow, India's domestic will grow. Then I asked, बताओ एक time बताओ. He said, sir, about 2060 tak I think we can catch up. So why do you say that? Because, sir, from now to 2047, under Vikshit Bharat, our target is to make India around 30 trillion dollars, correct? And by then, China probably would have become 60 trillion dollars. Okay, but if I take another 30 years, एक बार critical mass आ जाता है, I can grow very fast. And then tell me, what is government of India doing? You know, he didn't say things like, we are working on industries, we're working on infrastructure. He said very specifically. So look at our program called as PLI program, the Production Linked Incentive Program. So look at our Gati Shakti program. And then he gave us, so look at the growth of MSMEs. See, the concept kya hai? Concept is, India is expanding. The concept is, India can catch up. But when he puts numbers, when he puts programs names, when he says, what objectives are where, then the authenticity kicks in. Then I know this guy understands what he's telling us. So for any answer to show your depth, to show your understanding, okay, and even for analysis, you must have substantiated by some facts. अगर आपका आंसर में फैक्ट्स नहीं है, नंबर्स नहीं है, say think of this, Earth's interiors are layered, and there are different models that say so, and you keep quiet. And another guy says, Earth is layered, the different models, and these are the 3 models. The mistakes are these, the contemporary says this. Who do you think has more impact here? आपको हमेशा याद रखना है कि you are in a competition. Competition is not about achieving pass marks. अगर 100 आपका pass mark है तो आ जाएगा, ठीक है. Competition है. If somebody scores 100, you must score 101. If somebody scores 500, you score 501. So competition में you must develop your own edge. The same type of facts I would not be teaching if I was teaching probably 10 years ago. So as the time passes, as students know more and more, to keep the edge, you have to know more. It's typical like a competition market that you are into. Okay, so I hope I explained that कि ये जो data है, okay, एक तो don't get bogged down by this. How to remember this? Summarize this, and consciously memorize this. हमारा problem है कि we assume that पढ़ते पढ़ते याद हो जाएगा, ऐसे कभी नहीं होने वाला. Okay, so you have to know the numbers. This is the continental crust. This is the ocean crust. This is the upper mantle. This is the lower mantle. This is the outer core, and this is the inner core. So don't get bogged down by numbers. Put some efforts. You are a geography optional students. Your answer must have some details. Okay, so this is answering many of you telling me, sir, geography में बहुत कुछ याद करना पड़ता है. कि नो, कोई जबरदस्ती नहीं है, मत करो याद, कोई दिक्कत नहीं है. बट याद सिर्फ ज्योग्राफी नहीं, सब में करना होगा. In any topic where you want to show your mastery, geography, political science, you talk about economy, environment से लिखोगे कि India has problem deforestation, खत्म. कहां पर हो रहा है? बहुत जगह हो रहा है. कितना हो रहा है? बहुत ज्यादा हो रहा है. कौन कर रहा है? सब कर रहे हैं. Okay, I mean, look at the answer. क्या बनेगा आपका answer? But if you specify the Terai regions of Uttarakhand, because of rice cultivation, since the Green Revolution, the loss is approximately India में 1.5 million hectares of forest loss every year. The nominal growth is compromised by more than 70% because of your deforestation. Then I know you have packing a punch in your answer now. So facts, you have to know if you want to create an edge. ऐਵੇਂ करना है, हाँ कोर्स हो गया तो अलग बात है. ठीक है? So just to explain what your fears are. So I was discussing the conditions में we talked about the density change, and an important conceptual idea here is that the density increase is not only because of the pressure. Pressure important है, but the bigger reason is the composition. कि rocks ही change हो जा रहे हैं. The minerals are different. The upper layers, I used a term, there are felsic minerals. Okay, there are minerals like quartz, minerals like feldspar. When I go down, the mafic and the ultramafic minerals are there. I mentioned amphibole, pyroxene, olivine. So the minerals are changing, the rocks are changing, and that's why the density also changes. So that's one important thing. Second, we talked about the temperature. So initial layers, the temperature increases by a few degrees, but there are specific locations where we have higher temperatures. Higher temperatures at areas of tectonic activities, higher temperatures at areas when we enter the inner core, higher temperatures at the core mantle boundary, and inside the core it can be far, far more, 4,000, 5,000 and so on. Yeah. So temperature pattern idea हो गया, and temperature का source क्या है? The source is, I said, the residual heat plus some bit of radioactivity also. So interiors of the earth are not yet completely cold. Okay, it is cooling, but it is still having lot of heat of the time when it was a nebula. So nebula ka residual heat keeps the internal areas hotter. Temperature bata diya, and then I move towards what are the different models. So Edward Swiss model, then we talked about the model given by Arthur Holmes, the model of Daly, the model of Van der Graat. Van der Graat's model is closest to our present day understanding, where there is inner silicates, there are intermediate layers, mixed silicates, and zone of pure metals. So if you look at Van der Graat, इसमें crust का concept है, upper lower mantle का concept है, and the idea of core also is there. Okay, so Van der Graat's model is closest to the contemporary model. Yes, yes, of course. All of this is from the textbook. So let me finish some portions. Maybe today, if I have time later, I'll give you the pages also you can refer to. Can we say that Earth is formed by process of sedimentation? No, 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 please. Okay, sedimentation as a process is a very, very superficial layer. Okay, so see, it's like this. There is no other substitute to the idea called as gravity collapse. Okay, there is no other substitute to the idea called as nebular accretion. So please don't use any random words. Sedimentation means something. The Earth's formation is not sedimentation. Okay, the process is nebular accretion and gravity collapse. So keep it technical there. Okay. Then I moved on towards the more contemporary model. Okay. Now see, what I want all of you to do is, the next day when I have the class, like I'm revising, I want all of you to have a synopsis on your table. Okay. And while I'm revising, you have to keep on ticking off कि आपको याद है नहीं है. Okay. Otherwise, you are not revising properly with me. So make it a habit. Today onwards, very nice, Harish. ठीक है. So you go back and do a synopsis today. In the next class, you keep synopsis on the table and revise with me. Okay. You recall with me. So contemporary model, one model is based on the chemical composition. And I said there is a crust, okay, there is a mantle, and there is a core. And crust, I was explaining that the crust is the outermost layer, it is the coldest layer, it is a hard, and it is brittle, and the crust has oceans and the continents. Oceans and continents are two different type of layers. The oceans are not extensions of the continent. So इसका listing करा दिया था मैंने. The oceans are, now ये terms याद होने चाहिए. Basaltic, the oceans are mafic, the oceans are basic, the oceans, okay, the oceans are thinner, about 1 kilometer, in some places also 3 kilometers. Okay, and the continents in contrast are granite, continents are andesite, rhyolite, diorite. ये नाम याद है आपको all of you? And mafic है तो continents क्या है? Continents are felsic. The acidity, the base, the pH value is, it is more acidic and it is far more thicker. Okay, it can be around 60 odd kilometers, in places as much as 80 kilometers also. And oceans are denser, about 3.5. The continents are lighter, 2.5. So ये facts na on the tip of your fingers. How is the ocean crust different from the continental crust? Now while discussing here, I talked about how the ocean crust is more fundamental. When I say more fundamental, this crust was formed first. Okay, and then slowly, gradually, ocean se bana hai continent. Okay, and I used a term, I don't remember if I did, I think I did. This process is called as what? It's called as the process of crustal differentiation. ये भी बहुत important aspect है in the crust formation, that the oceans are creating the continents. Oceans से ही continents बन के आता है. For an analogy, I said, imagine the cream, जो घी है, it comes from the milk itself. So there's some process you put your milk to, some churning, okay, and उसी से आप निकाल लोगे butter. Okay, so the continents are created from the oceans. The process is called as crustal differentiation. Okay, but despite this, I said, while the oceans may have formed first, the oceans formed in the Archean times. Archean times, early Archean times. The continents were formed later. But in reality, much of the old ocean has been destroyed. We do not have oceans older than, I said, about 200 million years. बस continents में हमारे बहुत पुराने पुराने rocks हैं. Continents में we have rocks that goes back to 2.5, even 3 billion years. Parts of Canada, parts of Scandinavia, Norway में we have found such type of very, very old rocks. So that's about the crustal facts. Let me continue now. I'm done with the crust. The next discussion is on the mantle. The next, any doubts, anybody? Any clarifications? Online, offline? Any clarifications? Sorry? Just know that is a layer which has amphibole as a dominant mineral, that's all. Grandiorite is a layer that has more of granite and diorite. Ecolgites एक categories of minerals हैं, which are heavier than the amphiboles. So I think I gave the list of the minerals, right? याद है? नहीं है? I did, I think, yes. There is quartz, there is feldspar, there is mica. वैसे ही हमारे पास amphibole है, pyroxene है, olivine है. So when we have amphibole dominating, we call that as amphibolites. Essentially, वही आपका basalt and some of the olivine rich rocks of the mantle होगा आपका. ठीक है? That's how we know amphibolite. Crustal differentiation, Aniket, it basically means the crust itself has become different. Okay, पहले ocean था, उसी से अलग होकर continents आ गया है. Pravash, I'll explain that theory. अभी इतना ही लिखो. I'll come towards that eventually. Okay, about the mantle. Mantle is the largest layer, almost more than 80% by volume of the earth and more than 60% in terms of weight. And the mantle is from under the crust almost up to 2800 to 3000 kilometers from the surface. From just below the earth, crust. Okay, crust के नीचे मतलब below continents, below the ocean से लेकर almost 2800 kilometers or 29, this value doesn't matter, keep it round off there, up to 3000 kilometers from the surface. The mantle has 3 layers. Okay, we have the upper mantle, we have the middle mantle, and we have the inner mantle. Okay, the upper mantle is till about 350 or 400 kilometers from the surface. The middle mantle about 700-900 kilometers from the surface, and the inner mantle is where course शुरू हो जाता है. I said 2900 or 3000 kilometers तक. All the depth is measured from the surface of the earth. The 3 parts of the mantle, the upper mantle, the middle mantle, and the inner mantle. Okay, the dominant rock of the mineral, okay, the dominant mineral of the mantle is olivine and its variants. Olivine is the main source mineral, और उसके कुछ variants हैं. The main mineral of the interiors is olivine and its variants. Now, olivine का variants का नाम लिख लो. There are 3-4 names. Okay, the 3-4 names, the variants हैं. So there is garnet, there is spinel, and one more name, perovskite. Garnet, spinel, and perovskite. Spinel, N-E-L. Okay, these are some of the minerals of the mantle. Okay, they are very dense. Okay, and the rocks of the mantle. The rocks of the mantle. So, upper mantle में the dominant rock is a rock called as peridotite. In the upper mantle, the dominant rock is a rock called as peridotite. This rock is abundant in olivine. This is rich in olivine. Okay, but there are other variants. You remember two names. Okay, maybe one of them. No. One name. Other variant is a rock called as dunite. As we go down, some of the rock compositions will start changing. Okay, so that is about the mantle, and just know that the upper mantle has certain unique properties because of dominance of olivine. It has certain unique properties because of the dominance of the olivine mineral. Okay, and in terms of the state, what is its state? Okay, state is mantle is a solid. Mantle is solid, very high density. Mantle is solid and very high density. The upper mantle, okay, I said is around 4 to 5 density hai. The middle mantle, okay, has, so in terms of density, solid. The density is high density. The upper mantle has 4 to 5. The middle mantle around 5, 6 or 7. The inner mantle 7 to 9. Okay, some places even 10. So good density of the mantle. 4 to 5, 5, and round off these numbers, density. But then what happens is, the mantle in parts can be molten. Pura mantle molten nahi hai. In parts, the mantle is molten and it can circulate. In parts, the mantle is molten and can circulate. And can circulate as convection cells. The mantle can circulate as convection cells. Okay. Mantle is the main source of magma in volcanism. Mantle is the main source of magma. Okay, main source of magma in volcanism. In volcanism. और एक part add करो that within the mantle, okay, there are certain localized zones. There are certain localized zones of hot mantle magma. Of hot mantle magma, and not as a part of the convection cells. There are certain localized zones of hot molten magma and not a part of the convection cells. Let me explain this to you. Dekho. So this is say the continents, the oceans, the continents and so on. This is the core. And the mantle is solid and very dense. You go down, it becomes more and more dense. But what happens inside the mantle is, some parts of mantle can melt. Ye melt ho jayega because of internal heat. It melts, and this melting can melt this rock. These hot temperatures can melt this rock. It can melt this rock. Okay, some of this can come out as eruptions, but lot of it can also turn like this, okay, and can flow back like a circulation. It can rise up, it can turn like this and flow back like a circulation. It's like, you know, say for whatever reasons, inside the room there is a source of, say, smoke. Okay, the smoke rises if there are punctures, the smoke can escape through the roof, or the smoke can rise, hit the roof, and then turns kahin jaake thanda ho jayega, it'll come down again. Okay, and this is what is the convection circulations. Okay, so mantle mein aisa hota hai. Okay, hot molten rocks can rise up, circulate, and these cells can be of any depth. They can be very shallow. So yahin par rise kiya aur yahin par ye ho gaya circulation. Some of it can be very, very deep also. Okay, it can start from here and rise up, come down here, okay, and back like this. These are very deep mantle cells. I hope you all can imagine what I am drawing. Yeah? So inside the mantle is not a stationary thing. Okay, it is circulating. I know students will ask me, sir, फिर अगर circulate कर रहा है तो molten हुआ ना? Then why are you saying the mantle is solid? The analogy I give is, imagine our human body. Our human body is solid. Okay, the muscles, the tissues, the bone, solid hai. But inside our body, don't we have small conduits of blood circulation? We have small conduits of air circulation. Okay, inside the body, there's something going on. So वैसे सोचो आप, that the mantle is solid, but some parts of it can melt and start circulations. Those are called as convection. This is called as convection cell. The word cell means कुछ एक closed है. They rise like this, come down, and it closes. Any closed thing is called as a cell. Okay, animal cell, plant cell, prison cell, convection cells. We have got atmospheric circulation cells. कोई भी चीज जो बंद है, closed है, some kind of start and beginning, closed, it's called as a cell. This is a convection cell. And then I'm saying, apart from this, there are some locations where I can have a localized magma, and this hot magma can rise, okay, and can come out as eruptions here, and it is not a part of any convection cell. A convection cell hota, so this would have been circulating like this. This would have been circulating like this, right? But I'm saying there is no convection cell. It's a hot one directly rising up and maybe coming out as eruptions. These kind of phenomena are what's called as mantle plumes. P-L-U-M-E, mantle plumes. ये localized होते हैं, and they can cause some local volcanic eruptions. So mantle, yes, you're right. This was a question asked in the GS. Write a note on mantle plumes. Okay? I mean, the UPSC guys have become far more smarter. Rather than asking you a generic write about interiors of Earth, एक specific पूछ देता है. You tell me about the economy of India, तो आप कुछ ही बोल दोगे. Very specific. Okay, tell me about MSME's reforms in the last 10 years. The more specific they go, the more depth you need to have in your content. Okay, so they'll not ask you generic. They may ask, but they are going to this depth of questions. So mantle, I repeat, mantle का state क्या है? What is it in terms of its state? Mantle is solid, mantle is dense, the density increases as I go down the depth. Parts of mantle are molten and they are circulating like convection cells, and parts of the mantle are localized molten. जहाँ से कि we have got vertical lava coming out, we call that as mantle plumes. Plume is an English word for feather. How does a feather look like? So a feather has something like this, right? No? This is a feather. So any bird ka feather hai, plumes. This is a feather here. Right? So mantle plumes दिखने में ऐसा ही है. So some lava coming out like this. The lava comes out, rises, comes out, and eruption of volcanic landforms. The word plume means something is vertical, okay, and it's coming out, whatever it is. ठीक है? So these are mantle plumes, correct. Next start off. Yes, tell me. बहुत सारे issues हैं. Okay. Plumes also cause eruptions. When I take up volcanism, I'll explain a bit more there. I'll be just getting familiar with this. Let's move on. The next is about the core. The next is the core. The core is the innermost layer, the densest layer. Okay. Yeah, please keep writing. Core is the innermost layer. Core is the densest layer. Densest layer. And the core is beyond 2900 kilometers. The core is beyond 2900 kilometers. In terms of thickness, कितना है core बताओ? How thick is the core? Okay. So this was a question you asked. I ignored yesterday. Okay. So if Earth's radius is 6400 और आपका already 3000 जा चुका है, तो कितना रह गया आपका ये वाला? Okay. So 6400 minus 3000 is 3400. The radius is 3400. Okay. So if I ask the thickness, what do I mean by this? I mean essentially the diameter. One of you asked me yesterday, मैंने ignore मार दिया कि सर आप बोलते हो thickness radius is 6400. How can the thickness be 7000? ठीक है? Thickness का मतलब होता है the entire one. So this is layer 1, layer 2, and layer 3 is a circle. ऐसे सोच लो आप. So this is maybe 1000 kilometer. This is 2000 kilometer, and this core is approximately 7000 kilometer. I hope you got the point here. 3400 plus 3400, 6800. ठीक है? Round off that to 6000 to 7000 kilometers. Okay, let's move on. So core has two parts. Okay. Sorry? समझ में नहीं आया इसमें. ये एक लेयर है, ये एक और लेयर है, ये एक और लेयर है. ओके. से ये 0 डेप्थ है, ये 100 डेप्थ है, ये 500 डेप्थ है और रेडियस शायद 1000 है. तो मैं पूछ रहा हूं लेयर्स का थिकनेस क्या है? ये थिकनेस कितना है? 100. ये थिकनेस कितना है? 400. 500 माइनस 100. जब इसका थिकनेस पूछेंगे, I'll talk about the entire diameter thickness. ठीक है? तो अगर 1000 इसका रेडियस है और 500 600 जा चुका है, तो रेडियस कितना बचा आपका? 400 रेडियस बचा. तो थिकनेस कितना होगा? ये 400 प्लस 400. तो इसका थिकनेस हो गया 800. One of you asked me yesterday कि sir, why are you saying the core is 7000 kilometer if the radius is 6400 kilometers? क्या हम सेंटर के रेडियस से बाहर तक आप बोल रहे हो सर इतना है, और आप कह रहे हो कोर ही अपने आप में 7000 है, ये कैसे है? Okay, so when I say core का thickness, I mean the entire. See, if you get a metal ball, क्या thick है? क्या बोलोगे आप? दिखने में इतना बड़ा है. This is the thickness of the metal ball or a plastic ball or a football. How thick is the football? आप क्या बोलोगे? पूरा बोलोगे, right? So the thickness of the core is actually the entire diameter. समझा? ठीक है? Yeah, but I don't know your name. I'm sorry. Fine now? Who asked me? Oh, you asked me. I'm so sorry. Is it fine? Achha. Okay, let's move on then. So the core का दो part है. Okay, the core has two parts: the outer core and the inner core. The outer core 2900 kilometers से 4800 kilometers है. This is the thickness of the outer core. Okay, and the outer core has iron, it has nickel, plus it has certain silicates also, whereas the inner core is almost metallic iron and nickel. Outer core का density approximately around 11.5 है. The inner core has a density of 13.5. 13.5 corresponds with the atomic weight of iron itself. ठीक है? So the core का arrangement ऐसा है. Okay, it starts from 2900 kilometers up to 48 kilometers तक. उसके बाद beyond 4800 is your inner core. And the inner core, I said, it has iron, it has nickel, it also has certain silicates. And the silicates are like impurities. Whereas the inner core is largely metallic. That's what even Van der Graat had said, right? The inner, the core hai, the core is metallic. And it is predominantly iron and nickel. Density bhi unhone aise kaha tha, around 13.5 kaha tha, right? So what happens is, and remember, if core ka temperature, the temperature of the core is more than 4000 centigrade. 4000, 5000, इतने बड़े नंबर में 2-3 हजार ऐड कर लो, कोई प्रॉब्लम नहीं है. How old is the earth? 3 to 4 billion. Okay, और 3 बोलो, 4 बोलो, okay, एक आध बिना में ऐसे ही ऐड कर देना है, पानी मिला देना है. Okay, so don't bother about exact number कि 4, 7, 8, 5.37, ये करोगे मार्क्स कट जाएगा आपका. Okay, the examiner will have a complex. इतना जानता है फिर मेरा ही नौकरी चला गया टाइप्स. Keep it broad range में. Okay. Now with this kind of temperature, what happens is, if there are impurities in this will no longer remain solid. The basic physics chemistry hai that if you add impurities, the melting point will fall. If you add impurities, the freezing point will fall. That's why when you add ice mein, you put salt, it becomes even more colder, and that helps you freeze and keep ice for a longer time. So when you have impurities, इसका melting point जो है, it becomes less. Those who don't have science background, don't worry. रट्टा मार लो. Okay, beyond a point we say, don't struggle too much. देखा जाए science नहीं है, this is very elementary school. Okay, but ठीक है, नहीं समझ में आ रहा है, आप बस याद कर लो. Impurities are there, the melting point will become less means what? It will melt at a lower temperature. So this layer is a fluid layer. It is a fluid layer. It is molten. So if you look at the core, the outer core is molten and the inner core is solid. Solid, and it is iron rich. It is molten and very high temperatures. इतने high temperatures में क्या होगा? Electrons जो हैं, they become loose. The electrons become loose. Very high temperature, electron बाहर निकल जाएगा from the atoms. ठीक है? And they become loose. This molten and loose electrons, इस condition को बोलते हैं plasma state. It's called as the plasma state. ठीक है? प्रभाष याद करो, आगे बढ़ते हैं. Have impurities, okay, it will have lesser temperatures, okay, lesser melting point, okay, it will melt, it is molten, and with high temperatures, loose electrons, we call the condition as plasma state. Now imagine, this is, okay, this is the core here. I'm taking a cross section. Okay, think of this as the inner core. मैंने से आधा slice लिया है. Inner core is solid, and the outer core, because there are electrons here. And remember, इसमें भी this part is hotter and this part is colder. So इसके अंदर भी you'll have some kind of convection going on. Can you all imagine here? इसके अंदर भी some kind of convection is going on. Plus, Earth is spinning. So all of this will force the electrons to start moving inside the inner core. Okay, लिख लो यहाँ पर. The outer, not inner core, outer core. The outer core has loose mobile electrons. The outer core has loose mobile electrons that spin around the inner core. Okay, so वो spinning क्यों है? One is, as said, inside the core we can have some kind of convection going on, and then Earth be is spinning. Earth spin also will force some kind of motions in the inner core. And electron moving का मतलब क्या है? Electricity. Okay, so now we have, because of this arrangement, there is an electrical field. Sorry, there is an there is electrical field around the solid iron-rich metallic core. Because this condition where there are mobile electrons, there is an electric field, okay, around the solid iron-rich metallic core. Solid iron-rich metallic core. और ये जो arrangement है, okay, this arrangement is what will create Earth's geomagnetism. It creates Earth's magnetic field. Okay, a moving electrical field around a iron core is something like a dynamo. Okay, it will create, okay, a kind of, something like a electromagnet. Okay, this is like, if you know, एक iron rod अगर है आपके पास में, and around this, if you have some kind of a coil attached, okay, some type of a coil attached. I put a battery here. I put a battery here and join this. Okay, say positive, negative here. Because of this, okay, this rod will act like an electromagnet. Yes, this is what is called as a solenoid. Correct. So Earth's electric field creates this kind of conditions of magnetism. The genesis of Earth's magnetism is this one. The arrangement, a mobile outer core lose electrons because of plasma state, and the inner core is iron-rich metallic core hai. It will create an magnetic field called as the geomagnetism. And it kind of, reinforces each other. The magnetic field in return will make the electrical field stronger. Okay, the electric field will make the magnetic field stronger. It goes on like this. It's like a self-exciting dynamo. वो अपने आप काम कर रहा है. Okay, it is maintained by itself. Okay, it's something like, think of a condition where the car moving, you apply the brakes. Okay, the battery starts charging. Release the brakes, the battery can run the car. Again apply the brake, the battery can start charging. Typical what can happen if you're going down a hill. Okay, it is like a self-sustaining system eventually. So we call this system as self-exciting and a self-sustaining Earth's dynamo. Earth's dynamo. Self-exciting, a self-sustaining Earth's dynamo. Okay, this is the arrangement of the core, okay, the mantle and the crust. Any questions on this, anybody? So, इसको summarize कर लेते हैं quickly. Maybe in a diagram form, if I quickly put it here, this is the continent, this is the ocean, this becomes the crust. This is the upper mantle, middle mantle, inner mantle. This is the outer core, and this is the inner core. These are the boundaries we have. Okay. So you know about continents का thickness क्या है, ocean thickness क्या है. This is approximately 350, 400, approximately 700 to 900. This is 2900. This is 4800. Okay. This is fluid. This is iron rich. It is a solid. This is having a density of 11. This is 13.5, about 9, about 5 to 6. This is about 4 to 5. Continents 2.5 to 2. This is 3, 3.5. Summarize this in a diagram form and whatever you can add. This is the structure of the Earth's interiors. So, जो detailing है, I am keeping in mind a short note if they ask you only about one layer. Okay, अगर पूछा कि write about core alone, तो उतना content होना चाहिए to last you for 1.5 page with diagrams. Aniket, I have done that now. All good? Can I move on now? Okay. This is one scheme that is popular. The second scheme is the mechanical differentiation of Earth's interiors. The mechanical layering. And mechanical layering is based on rigidity. It's based on rigidity. In Delhi, the summers have now kicked in. Okay, mornings are a bit cold and chill, evenings also, but afternoons are warm, pretty warm. AC ka time aa gaya ab. Anyways, can I please summarize? Beta, kya kar raha tha main? Ye summarize to kar raha tha. और क्या summarize करें बताओ? Your network issue, fine. Maybe you can watch the recording for that part. Okay. I just drew the diagram of the continent, ocean, upper mantle, middle mantle, inner mantle, outer core, inner core, and I gave the values of the depth. तो आपको जो ऐड करना है इसमें ऐड कर लो for detailing. I think I told this to you. Your summaries, I have to use more and more of diagrams. So imagine इस diagram पे, if I can put an arrow and maybe detail something here. I put one arrow and I say something here. Okay, the entire 7 pages of lecture is done. Yes, Debarga, correct. Okay, let's continue. Now, when I'm saying mechanical layering or differentiation rigidity wala kya hai, this is in terms of the strength. It's about the strength. Strength, we say there are 4 layers. There is a lithosphere. There is a layer called as asthenosphere. There is mesosphere, and there is barysphere. There are 4 layers in terms of rigidity, in terms of strength. The lithosphere, the asthenosphere, the mesosphere, and barysphere. Now, to draw the analogy, I think I told that yesterday, say this is the crust. Continents, ocean, crust ho gaya. Continents are thicker. There is upper mantle, there is middle mantle. इसी के analogy में, okay, this is the entire thing is upper mantle. This is up to 350, 400. Upper mantle का ही एक part, okay, this layer is called as the lithosphere. And upper mantle का जो remaining part है, okay, this is called as the asthenosphere. Okay, so this whole thing is upper mantle. Okay, and this is up to 100 kilometers. And this, of course, stays at 350, 400. This is the main concept. The remaining middle mantle and the inner mantle, ये दोनों मिलाकर we say this is the mesosphere, और जो core है we call this as the barysphere. The lithosphere is the crust and the upper part of upper mantle up to 100 kilometers. The lithosphere is the crust plus the upper part of the upper mantle. Crust plus the upper part of the upper mantle up to a depth of 100 kilometers. Up to a depth of 100 kilometers. Okay. Next is the lower part of upper mantle. The lower part of upper mantle is the asthenosphere. The lower part of upper mantle is the asthenosphere. Asthenosphere, A-S-T-H-E-N-O-S, the asthenosphere. Okay. So the rest is the same, no issues. Now, small discussion about this. Okay. Now, why are we putting the crust and the upper mantle together? Although they're different in terms of their composition, they're different in terms of the rocks and minerals, but they behave as one layer. It's something like, if I look at my body, my skin itself is 3 layers. The upper epithelium, the middle epithelium, the lower epithelium. Okay, ये 3 अलग layers हैं, but the whole thing behaves as one layer. वैसे if you look at your walls, the paint, the distemper and the POP are 2 अलग layer, but they are so well fused together, they behave as one layer. So for all practical purpose of strength, not in terms of composition, how strong they are, in terms of strength, okay, they have almost common strength, the crust and the upper mantle. Okay, that's why we keep them together as one layer. Write down this one here. The crust and the upper mantle, behave as one layer, and comparable rigidity. They behave as one layer and comparable rigidity. 3 more facts. The lithosphere is the lightest layer of the earth. Lightest layer of earth. Number 2, the lithosphere includes the oceans and the continents. The lithosphere includes the oceans and the continents. Number 3, the lithosphere is cold and brittle. The lithosphere is cold and brittle. Brittle means something which cannot be deformed, वो टूट जाएगा. Like think of iron rod. If I bend an iron rod, I can bend it. Okay. Iron metal is malleable and ductile. हम उसको bend कर सकते हैं. But think of a glass sheet, कांच का sheet. आप हल्का से bend करोगे टूट जाएगा, right? So iron is not brittle, but glass is brittle. टूट जाएगा. Okay. So lithosphere is light, it is hard, cold and brittle. If I apply pressure, it will break. Okay, right now, the lithosphere is not continuous layer. The lithosphere is not a continuous layer. it is broken into segments called as plates. It is broken into segments called plates. Segments called plates. ठीक है? The next fact about asthenosphere. Asthenosphere. The asthenosphere, within bracket approximately 300 kilometers thickness, approximately 300 kilometers thickness, the asthenosphere is rich in olivine, and olivine has a unique property. It is rich in olivine, and olivine has a unique property. It is capable of deformation and can flow. It is capable of deformation and can flow. It becomes a fluid. It can flow under stress and pressure. Under stress and pressure. The analogy could be, think of a sponge or a rubber. Rubber is solid, right? Okay. Sponge is solid. आप अगर अप्लाई करोगे प्रेशर तो क्या होगा? It starts to expand और फैल जाएगा. Remove pressure, it'll again bounce back. Okay. तो crudely like that. ऐसे में asthenosphere solid है. You apply pressure to it, it'll start flowing like a liquid. Remove the pressure, it'll again become solid. Now, this is a unique property which other minerals don't have. It's unique to olivine. That is why the asthenosphere also has that behavior. The asthenosphere is capable of flow. And because in English and in physics, we do not have a separate name for this behavior, we call the layer as semi-molten. So semi-molten bolte hi, don't think it is flowing like a liquid. It's just a convenient phrase to explain what it may look like. Head down. It is because of this nature, that asthenosphere is considered to be semi-molten. Asthenosphere is considered to be semi-molten. Okay. So arrangement क्या है? Arrangement is the hard, broken segments of lithosphere, okay, plates. The hard, broken segments of lithospheric plates are floating over the asthenosphere. The hard, broken segments of lithospheric plates are floating over the asthenosphere. So we have the layer of asthenosphere. इसके ऊपर में there is a slab of lithosphere. There is another slab of lithosphere, another block of lithosphere, and they are floating. Okay, the asthenosphere is like a layer underneath. Okay, write one point, put a star mark and write down. The older concept was the continents. The older concept was the continents within bracket Sial. The Sial, within bracket Sial, okay, is floating over, the Sial is floating over, okay, the oceans, within bracket Sima. The old idea था that the continents float over the oceans. Now we know the continents and the oceans side by side as part of lithosphere. they float over the asthenosphere. So continents are not over the oceans. ये गलत है. It is continents along with the oceans side by side. They are part of lithospheric plate and they are floating over the asthenosphere. The continents don't float over the oceans. The continents and oceans side by side, as part of lithospheric plates, they float over the asthenosphere. All fine here? So that completes our discussions of internal structure of the Earth's interiors. Take up a fresh page. Evidences of interiors. Evidences of Earth's interiors. This is a possible question, both in GS, okay, and in your optional. GS में you will not need to detail too much, but optional, of course, you'll have to detail. Evidences of Earth's interiors. Ashish, mantle is solid, but समझाया ना मैंने, mantle का above part is not rigid solid. It is not a rigid solid. Oh, okay, fine, Piyush. अच्छा ठीक है. Before I start off with the evidences, maybe short अगर जगह है, maybe 1/4 of a page types. Just write down 3-4 things. Okay, I forgot to mention that. Thanks, Piyush. So, nothing big deal. Discontinuities. These are those layers where the two different layers get separated. We call those as discontinuities. So, if this is the continent, this is the ocean, okay. This is where the mantle starts, and this is the upper mantle, middle mantle, this is the core, the inner and the outer core. The upper mantle, the middle mantle, we have the inner mantle, the outer core and the inner core. Okay. So there are some layers. Just remember the layers ka names, nothing much to add here. There's one layer which separates the crust and the mantle. We call this as moho, M-O-H-O. There's one layer that separates the middle and the inner mantle. इसको हम बोलते हैं repeti or the birch. There is one that separates the inner mantle and outer core. We call this as Gutenberg. There's one that separates inner and outer core. We call this as Lehman discontinuity. So moho separates the crust and the mantle. Repeti is middle mantle and inner mantle. Gutenberg is mantle and the outer core. This is the outer core and the inner core. That's all. We call these as discontinuities. All of these are called as density discontinuities. Moho, Repeti and Gutenberg. We call these as density discontinuity. As in they separate the rocks of different densities. Okay, of course, composition bhi to hai. Okay, so density lighter, a bit more. Lighter, a bit more. Okay, lighter and a bit more. Layman को बोलते हैं as a phase discontinuity. Because this is liquid, this is solid. Phase is what? State of matter, right? The layman is called as phase discontinuity. It separates the liquid phase of outer core from the solid phase of the inner core. Birch, B-I-R-C-H. B-I-R-C-H. Birch discontinuity. Nahi, Komal, there are 15 of them, all of which I will not know. You don't need also, just know this much, that's all. How plasma is one type of molten E. Okay. Fine, all of you? Okay, let's move on. Come towards evidences of the Earth's interiors. So, evidences mein that evidences, so Earth's radius is 6400 kilometers. To study and to know the interiors, we need inferences, okay, some of which will be direct and some of which will be indirect. Okay. To physically go inside and check the rocks, it is not possible. So what we do is we study and know the interiors by inferences. The inferences can be direct ones or they can be indirect inferences. Okay? Now, what do I mean by direct? It is based on study of some material. मैंने rock पढ़ लिया, मैंने lava को देख लिया, I probably studied some sediments maybe. So when I am studying rocks and sediments in the mines, when I study sediments and rocks at the locations of oil drilling, when I am studying volcanic rocks, volcanism अंदर से बाहर आ रहा है, when I am studying meteorites, end of the day, Earth was formed more or less by the same process as other celestial bodies. Okay, जैसे मून बना, जैसे मे बी मार्स बना, जैसे शायद जुपिटर बना, वैसे कुछ अर्थ भी हुआ होगा. When I study meteorites, those lumps of rocks that strike our Earth's surface, so ये चारों केस में I am studying a body, I am studying some rocks or sediments. We call this as direct. But lot of studies are based on, okay, say a study of, okay, waves, a study of radiations, the study of densities. For example, how do I know that Mars में Jupiter में क्या हो रहा है? I know that by studying radiations. The fact is, I am yet to get back rocks from there. Okay. How do I know a universe expand हो रहा है? I am studying some frequencies is coming, okay, and we are detecting it. So this is not study of a material physically. आप कुछ radiation देख रहे हैं, कुछ thermal imaging देख रहे होगे शायद, and you know it. So we call these as the indirect studies. So these are in some ways very accurate also. If I know how to infer, I can know fairly well what exists. Like think of remote sensing. Okay, remote sensing is based on some light studies, some radiation studies. Okay, I capture some radiations coming out. Yeah, something of that kind. This is indirect. Now, one of the most important indirect studies are the study of the seismic or the earthquake waves. The study of seismic or the earthquake waves. They can tell us something about the Earth's interiors, seismic or the earthquake waves. Okay? Now, before I detail what the evidences are, quickly 1, 2, 3 points. The first point is, earthquakes earthquakes, they release energy. Because the vibrations, okay, they release energy. Now this energy can be of two types. It can be electromagnetic radiations, infrared, maybe, okay, radio waves, or maybe you have got your ultraviolet rays, okay, they are radiations. And then there are vibrating particles. Radiations में particles vibration नहीं, बस energy move कर रहा है. Like think of solar radiation. Of course, sun is now, or solar radiations have dual properties. वो particles हैं भी और नहीं भी. But if I ignore the particle thing, I'm sure you know about gamma rays, X-rays, ultraviolet. ये particles नहीं है. Okay, it is some energy that's moving. Whereas there are particles which can vibrate. Okay, so these vibrating particles, they create what's called as mechanical waves. There are electromagnetic radiations and there are mechanical waves. Okay, now an important point here. Agar particles हैं and they're vibrating, the particles belong to a medium. Say the medium is maybe a plastic body. When energy passes, the particles of the plastic will start vibrating. When I am speaking, okay, the sound waves, they start vibrating the particles of the air. When I speak into an iron rod, the particles of the iron rod start vibrating. So mechanical waves or vibrating particles, they need medium. They need a body through which they can pass. Okay? Agar vacuum hai, there is no air, nothing, then even sound can't move. Okay, we can insulate it by having vacuum. Okay? Now, in this case, what happens is, the particles vibrating depends on what type of particles they are. Say I am speaking, on one hand I have an iron rod and I have a plastic rod. When I speak into iron rod, the particles of iron rod will vibrate in some way different from how a plastic particle vibrates. Okay? And if I know the vibrations, I can also guess the body also. मुझे पता है कि sound waves in iron, they behave like this. And I know the body has to be iron. Okay. In some medium, the particles behave like this. And I know that medium has to be plastic. There is correlationship between the property of the wave and the medium ka composition. The same wave while moving through plastic will behave in some ways. The same wave moving through iron will behave in some other ways. Because ये correlated है. If I know the wave and their properties, I can guess the medium. And if I know the medium, I can guess the wave also. They both are like signature relationship. An analogy I gave the students in the other class, it's like imagine that there are three people. Okay, one person makes me happy, another person probably makes me angry, a third person maybe makes me sad, and the relationship is ekdam one-to-one, a unique relationship. So if for some reason I am happy, you can guess, oh, I must have met the person who makes me happy. If I am sad, you can guess, oh, probably I've met the person who makes me sad, and so on. So if I know how the wave behaves, I can know what the medium is. So this is a earth body and some wave is going. While going, the wave has property A, property B, property C. I can guess कि वो जो rock होगा ना ऐसे वाला rock होगा. While moving, the wave changes towards property X, property Y, property Z. Because change हो गया उसका property, I know, अच्छा rock भी change हो गया शायद. So how they know this, वो अलग story है. But know that the property of the waves and the property of the medium are related to one another. If I know the wave property, I can guess what the medium is. Is it okay, all of you here? Okay, now write down. Earth's interiors can be studied by, studying how the seismic waves behave. Studying how the seismic waves behave as they propagate through the Earth's interiors. As they propagate through the Earth's interiors. As the waves move, their velocity and the path of propagation can change. The velocity and the path of propagation can change. And studying how the waves change, can tell us about the interiors. Okay? This is the philosophy. The principle क्या है? If I ask a question, what is the basis of seismic evidence of Earth's interiors? Why are we studying the Earth's interiors through the seismic waves? ये answer है. The basis is there is correlationship between the property of the wave and the property of the body through which they pass. And we can anticipate the changes if I know, or the medium if I know the changes. All good here? Okay, now, what are the types of earthquake waves? What are the types of earthquake waves, earthquake or seismic waves? What are the types of earthquake or the seismic waves? Yes, correct, Harish. You study the seismograph, correct. The seismograph are the instruments which can record the earthquake waves, right? Okay. Yes, Anisha, you're right. Okay, now, the types of earthquake waves, broad category, okay, they are surface waves. The surface waves can be of two types, the L waves and the R waves. Okay? The L waves, also called as love waves because of some scholar's name, love waves, and these are transverse waves and cause maximum damage in earthquakes. L waves or love waves, just remember this, they are transverse waves. Transverse का मतलब होता है the particles vibrate at 90 degrees to the propagating axis. They're transverse. Okay. Transverse waves, T-R-A-N-S, okay, V-R-S-E, transverse waves, and they cause maximum damage in earthquakes. The earthquakes में ना अगर building rise and fall करेगा ना, building will not collapse because your beams and your pillars are designed to take vertical load. अगर आप एकदम vertical rise करोगे और नीचे आएगा ना, the building will not break. The building breaks when there is, okay, this type of, we call it a sway. Okay, if your building starts moving side by side, then the building will break. That's why in earthquake resistance, what we do is they strengthen the corner of the buildings. Okay, corner में डाल देते हैं extra steel, so that ये sway वाला factor जो है, corner अगर lock हो गया, फिर ये sway नहीं होगा. Okay, so transverse waves, they move like this. So if the energy is moving straight like this, the particles start vibrating, okay, 90 degrees along the plane of the wave. So ऐसे होगा, the whole building starts moving side by side, and then we have the damage. So remember this: the L waves are the most destruction. Why? Because okay, they cause maximum sway deformations. They cause maximum sway. Sway का मतलब होता है side by side movement. They cause sway deformations. That's why L waves are destructive. R waves, also called as Rayleigh waves. Rayleigh waves, they are rotational. Okay, they move like this, like rotation. They also cause damage, but these are more damaging. Okay, Rayleigh waves, they are rotational. R for rotation, R for Rayleigh. Okay, the particle will go forward, come back, again go forward and come back. Okay, so a body will rise, will move ahead, will come back. Okay, so this is dangerous, but not as much as the L waves. Okay, so ये दो waves हो गया. Another type of waves are the body waves. Body waves are of two types. The body waves are primary waves, also called as P waves. The body waves are secondary waves, also called as S waves. The P waves are the longitudinal waves, and the secondary waves are again transverse waves. There are two types of body waves, the P waves and S waves. P for primary, S for secondary. The primary waves are longitudinal waves and the secondary waves are transverse. And again, the name suggests something. Say if this is the direction of energy transfer or energy movement. If this is the direction how energy is moving and the particles vibrate up and down like this. The particles vibrate up and down like this. Okay, this is a transverse wave. The energy is moving like this and the particles are vibrating like this one. But if the particles are vibrating, okay, say axis इसका ये है, and the particles vibrate to and fro along the same axis. They are vibrating horizontal, आगे पीछे हो रहे हैं, to and fro along the axis. We call this as longitudinal, and we call this as transverse. Okay, यही transverse waves are also L waves. Difference क्या है? L waves में क्या होता है? L waves में this is the axis of energy. L waves में the particles are vibrating like this along the plane. ये भी 90 degrees है और ये भी 90 degrees है, correct? Okay, so L waves में it is on the horizontal plane. In this, it is the vertical plane. So this is L waves, this is the S waves of the body waves, and this is the P wave of the body wave. You must have some idea about, because they are asking, last prelims mein they asked something on P and S waves. Okay, you have to know a bit more than otherwise. So Aniket knows, okay, it's part of the GS class, fine. So I told there, how do you remember? You better remember कि love है तो damage होना ही होना है. Okay. So So one of them said, "Kinesis a destruction." That's experience. Okay, if you have faced destruction and disintegration, okay, fine. Okay, आपका जो था किस्मत जो था और क्या? ठीक है? Aniket says no. Okay, fine. May your friend's experience. Then you are responsible for that. Okay, fine. बहुत सारे रिश्ते दोस्तों के वजह से बर्बाद हो जाते हैं. Both of them have interest in same person. Okay, then choice is okay. Yeah, the choice is okay. Either live with it or okay move on. And the guy who moves on generally becomes a UPSC aspirant. Okay, दिल में prove करना है ना कि अच्छा you do not know what you have missed in life. Okay, so many of them end up in ORN. Okay, so fine, dangerous topic. Okay, I don't want to upset you on this one. Let's talk about Earth. Let's go beyond. ठीक है? Okay, fine. Let's move on. So these are the possible, types of waves. Now, one property you must know is, जो P waves होते हैं, or the longitudinal waves, same as sound waves. And sound waves, they can travel in any medium. They can travel in water, they can travel in air, they can travel in solids. Okay? So sound can travel in any medium, but there must be a medium. Agar vacuum hai, okay, the wave can't move. Okay, sound wave is an example of P waves. And then there are S waves. Think of a plucked guitar string. You have a string जो आपने tight पकड़ा है and you pluck it. तो आपको दिखाई देता है ना एक wave ऐसे जा रहा है. Okay, it's only possible when the string is pulled tight. It must be rigid. अगर ढीला कर दिया आपने, you'll have no plucking. Correct? So S waves, they can travel only in rigid solids. Only in rigid solids. Okay. In liquids and in gases, they cannot travel. They cannot travel. जैसे ocean waves हैं या water waves हैं. Okay. You have seen waves, right? Rise and fall. Okay. Waves are example of transverse waves. But how are the waves possible in the water? Because the water surface has surface tension. Yes, so waves as a phenomena पानी के अंदर नहीं होते हैं. उसमें अलग टाइप के waves होते हैं. But the waves that we know, they are not features of, okay, below the surface. Surface में there is tension, water tension होता है, surface tension होता है. That's why you can have the wave-like features. You require rigidity. Okay, so I hope you understand this. P and S waves के property है. P waves are sound waves. Okay, sound waves, they travel in any medium. Whereas S waves can travel only in the solids and if they are rigid. अगर soft होगा, I will not have waves. It's like a tarpaulin. एकदम tight पकड़ा है, you can bounce on it, right? It is tight. But think of a loose bed sheet. Bed sheet भी solid ही तो है. But you can't bounce on that, can you? Because there is no rigidity in that. Okay, that's one. Another very important property is both P and S waves, velocity increases with increasing rigidity and with increasing density. If density is more, the velocity is more. If the rigidity is more, the velocity is more. L wave is one type of S wave, Satyendra. L waves are a type of S waves. But we don't use the word S waves, we keep it separate for the body waves. both P and S waves, velocity increases with increasing rigidity and increasing density. The wave velocity of P or of S is a function of the density of the medium and also the rigidity of the medium. Like it depends on both the factors, density and rigidity. Okay? So two things. One is, I said, S waves cannot pass through liquids. Yes, and P waves can pass through all the three. Whereas the both P and S waves, they become faster when the density is more and when the rigidity is more. All good till here? Okay. These are the properties. Now, inferring the Earth's interiors on the basis of the P and S waves properties. Inferring the interiors of Earth on the basis of P and S wave properties. इसके लिए साइड में you must remember what the layers are. There is crust, there is upper mantle, there is lower upper mantle, there is middle mantle, there is deeper or inner mantle, outer core, inner core. Correct? The crust is continents and oceans. Oceans are thinner, continents are thick. The upper mantle is the asthenosphere. याद आ रहा है? The lower middle mantle, upper mantle is, sorry. The upper mantle is part of lithosphere. This is part of the lithosphere. The lower upper mantle is the asthenosphere. This is solid and dense, solid and very, very dense. This is fluid, and this is solid and also very high density. So when the waves are going through this, the properties will change accordingly. So the lower layers, remember, is lighter. याद आ रहा है? हल्का है. Okay. Light layers, the speed is less. When they enter, the parts of upper mantle, they'll become faster. When they enter asthenosphere, because it is not as rigid, they'll become slow. They'll again become fast and very, very fast. And यहाँ पर, the S waves will disappear. Because fluid hai, they can't move through this. The P waves will move, but the P waves will become slow. They again become fast here. So if you know the layers ka properties kya hai, and then we can map it with how do the waves behave. Take all fine here? So ध्यान में ये चीज रखना. For scholars, they have gone studying the interior waves, they know about the interior layers. But now that I know this, I'm trying to correlate with what their observations was. Okay? So start off. So 1, 2, 3, 4 point. The first point. The first point here is, in the initial, by the way, before the first point, you can add a star and write down. We study the shallow earthquakes. We study the shallow earthquakes. There is earthquakes which are near the surface. We study shallow earthquakes or earthquakes which are near the surface. What do I mean by that? कि देखो, earth interiors में I can have earthquakes anywhere. But मेरा objective क्या है? The objective is to study the earth's interiors. So it's best if I study an earthquake जो यहाँ पर है, so that I can study the behavior of the interiors as the wave passes completely. Okay. I can study even this one. But this में क्या होगा? Probably I'll miss out knowing about this layer. ठीक है? So the convenience is, let's assume that the earthquake, वो वाला उठाओ, जो surface के एकदम पास में है. So when it's moving, I can know all the layers at which they passing through. Okay, so we study the earthquakes which are near the surface. Write down first point. The first point. The P and the S waves, the P and the S waves in the uppermost layers of the crust, in the uppermost layers of the crust are relatively slowest. They are relatively slowest. Slowest within bracket because the crust is the lightest and least dense. The crust is the lightest and the least dense. No problem? Next point. The P and the S waves, the P and the S waves, both in the continents, in the uppermost layers, in the continents, in the uppermost layers, are even slower. They are even slower. Okay. Put hyphen. The P velocity, P wave velocity is approximately, the P wave velocity is approximately 5 kilometers per second. The P wave velocity is about 5 kilometers per second. Again, देखो अगर आपका GS है ना, the detailing I don't bother. I don't even tell the students in GS. In the optional, you have to know a bit more. Don't just say slow and keep quiet. Tell us how slow. Okay? The uppermost layers mein they are slow. Continents mein they are even more slower because continents are granitic layers and they are very, very lighter rocks. Okay? And P waves ka speed this much hai. The next now, right next. The P and the S waves, correspond to the granitic layers. The P and the S waves correspond to the granitic layers and are called as PGSG waves. They're called as PGSG. PG as in P granite and S granite waves. They're called as PGSG waves. Fine. Next point. Inside the continents, after about a depth of 15 to 20 kilometers, inside the continents, after a depth about 15 to 20 kilometers, both the P and the S waves pick up speed. Both the P and the S waves pick up speed. Anybody knows why? Okay, I have got continent here and this is the ocean layer. मैंने कल कहा था ना, ocean is approximately 1 kilometer. 1 kilometer में you not have too much of variations. Continent is huge, thick. 60 kilometer की बात कर रहे हैं. So in this, the above rocks are more lighter than the rocks below. याद आ रहा है? The upper rocks are relatively more felsic. The lower rocks are relatively more mafic. देखो, ये mafic rock is not same as basalt here, but variation is not typical felsic here. So there is one layer here. When you cross this layer, the speed becomes very fast. Okay, this is about 15 to 20 kilometers ke depth mein, and this layer is called as the Conrad discontinuity. Write down that this layer corresponds to the Conrad, C-O-N-R-A-D, the Conrad's discontinuity. Conrad's discontinuity that separates the upper felsic layers, from the lower relatively mafic layers. That separates the upper felsic layers from the relatively Okay, more mafic layers. ठीक है? ऊपर के layers are more lighter, the lower layers are a bit more denser. There is a sudden change of speed here. Next. Both the P and the S waves, pick up speed beyond the crust. They pick up speed beyond the crust. While crossing the Moho's discontinuity. I hope you remember. Okay, this layer here is called as the Moho's discontinuity. याद आ रही है वाला? There's a Moho's layer here. Okay, यहाँ पर कितना speed है? About 5 of the P waves. By the time they come here, they become faster. And when they cross, they become even faster. Their speed increases from approximately 6 kilometers per second to about 7 kilometers per second. You know, the speed increases from 6 kilometers per second to about 7 kilometers per second. 7 kilometers per second. Okay? And all the speed I'm giving for the P waves, because I've checked the books. Most books don't tell us about the S waves. But ye jaan lo, of the P and the S waves, the P waves are faster. Okay? So S, hota hoga, we ignore it. Okay? Okay? Next side down. The P and the S waves, next point. The P and the S waves continuously become faster. They continuously become faster. But at around 100 kilometers depth. अब क्या होने वाला है बताओ? At around 100 kilometers depth. Okay. They become suddenly very slow, or they become suddenly slow. Yes. 100 क्या है? 100 is the boundary of lithosphere and asthenosphere. So they were slow, they become fast, they become more fast while crossing the Moho. They keep on become fast and suddenly they become slow. Okay. So while crossing 100 kilometers, which is the, within bracket, the lithosphere asthenosphere boundary. The lithosphere asthenosphere boundary, the waves become suddenly slow. Okay, the P velocity falls from about 7.8 kilometers per second to about 7.3 kilometers per second. The speed of the P waves falls from 7.8 kilometers per second to about 7.3 kilometers per second. Okay. The slowing down of the waves is because of the asthenosphere, which has lesser rigidity. The slowing down of the waves is because of the asthenosphere, which has lower rigidity. Okay. The asthenosphere therefore is called as LVZ, as in low velocity zone. It's called as the LVZ or the low velocity zone. Next, the P and the S waves, next point. The P and the S waves consistently become faster thereafter. The P and the S waves consistently become faster thereafter with the increase in density and rigidity. Next, beyond 700, 900 kilometers, beyond 700 and 900 kilometers, okay, the P and S waves, the P and S waves are very fast. The P and S waves are very fast, almost more than 10-11 kilometers per second. Almost 10-11 kilometers per second. This corresponds to the deep mantle. This corresponds to the deep mantle. Therefore, the deep mantle is also called, HVZ, high velocity zone. Is also called as the HVZ or the high velocity zone. Okay? So 5. The upper continent above the Conrad layer. Then we have the waves below the Conrad layer. Next, while crossing the Moho. Next, while crossing the lithosphere asthenosphere boundary. Next, while entering the deep mantle. Yaad rahega aapko, all of you? If you remember the layers, you'll have no problem. Okay, I repeat. Upper continent, lower continent, crossing the Moho boundary, crossing lithosphere asthenosphere boundary, and crossing into the deep mantle. Okay, the granite velocity, the lower mafic velocity, the velocity into the lithosphere upper mantle, the velocity in the asthenosphere low velocity zone, and the velocity in the deeper mantle high velocity zone. Fine? Next slide down. अब क्या होगा? The things will change. अभी तक क्या है? Okay. Till now, there are P and S wave. They exist as a set. ये together चल रहा है. They are pairs. Okay. But once I cross the deep mantle and I start entering the core, which is a fluid core, अब S waves जो हैं, they will not go any further. Okay. And that's how I know कि आगे शायद fluid है. How do I know this? So when the S waves are moving, for some reason, S waves have stopped moving. Whereas the P waves, they continue to move. Next point. Next point. Beyond 2900 kilometers from the surface, beyond 2900 kilometers from the surface, within bracket mention, corresponds to S wave exit angles. It corresponds to S waves exit angle of 103, 105 degrees. 103, 105 degrees. The S waves do not propagate. The S waves do not propagate. Okay. So what I have is, beyond 2900 kilometers, and the 2900 kilometers corresponds to, some angle of exit 103, 105 degrees. Uske beyond, the waves will not travel. Now, to explain that, you understand refraction, right? Refraction is what? Bending. And bending because of what? Bending because of difference in the density, right? So if there's a medium, this is air medium, and this is water medium, and ये normal है, अगर ये light आ रहा है like this, because of refraction, the light will not go straight, the light will bend towards the normal. This is the normal. Okay? So in light में क्या होता है? While moving from less dense towards more dense, the bending is towards the normal. ठीक है? In case of P and S waves, which are mechanical waves, उसमें भी bending होता है, but the bend उसका उल्टा होता है. Okay. In P and S waves क्या होता है? अगर ये है, okay, your normal, and this is less dense medium, and this is the more dense medium, when the P and S waves come, okay, when they cross a denser medium, they will move outwards, not inwards. इसका reason है that in the denser medium, देखो light में ऐसा होता नहीं है. In case of mechanical waves, denser medium में their speed becomes more. Light का उल्टा होता है. Light में क्या होता है? The speed becomes less. Okay. So because the speed becomes more, okay, उसका compensation है, it moves outward. In this case, the speed becomes less. इसका compensation है, it moves. If I want to give an analogy here, देखो. If the same medium was there, the distance is this much I must cross. ठीक है? Say the speed is 10. Okay? In the water जो dense है, the density maybe is say 20 for example. Light के case में it becomes slow. Because it becomes slow, it will now take a shorter path so that it can maintain the same speed ultimately. Okay, so this distance is long distance, correct? It will take a shorter path. इसलिए pass आ जाता है and comes out here. In case of the mechanical waves, they become fast. They become fast, so they must take a longer distance to maintain the same speed. It is kind of a balance that they have. Okay, you remember this, that light and P and S waves में difference क्या है? The P and S waves का velocity increases with density. That's why they bend outwards. So remember this, that the P and the S waves, okay, while moving through mediums of different density, they will bend and refract. They will bend and refract. Okay, when moving from a less dense to more dense, they bend outwards. When they move from less dense to more dense, they will bend outwards. Right? ये outwards है ना, ये वाला is bending like this. ये outwards है. ये surface है. Well, coming inside, they'll bend outwards. So if the waves are moving, okay, ये layers हैं. These are the layers. They are the layers. The energy comes from here, comes here, goes outward. Comes here, it goes more outward. It comes here, it goes more outward. So ultimately क्या होगा? इसका path is like this. It will not go straight. It now bends outwards. So if you look at the S waves, अगर S यहाँ पर है, the S waves will bend like this. They will bend. This is another proof that as you go inside, the waves are, the layers are becoming more and more dense. Okay, remember this point. ठीक है? So what happens is, when the S waves are coming, somewhere they become tangent and they come outside. Okay. This point, if I draw a line with the center, और ये axis है. Okay. This angle is 103, 105. Which we write here that ये angle represents this degree. And by using geometry, if I know the angle, I can know what is the depth here. This depth is 2900. So they do calculations on this and they know this. That's what I was telling you, that the S waves, okay, they can't enter the outer core. यहाँ पर they are blocked. But any one which is tangent can come out and exit at this angle. Okay? So I hope you got the diagram, all of you. You can redraw if you have not drawn it. This is your core. The waves turn like this. Okay, the waves, ये S waves हैं. This is the S wave diagram. They turn like this. This angle corresponds to 103, 105. Okay, and this corresponds to a depth of 2900 kilometers. And iske beyond, there is no S waves. There are no S waves. We call this as the S shadow. This is the S shadow zone. So अपने notes में just add one sentence. The pattern of S waves is as shown in the diagram. That's all. इस समझने की जरूरत नहीं है. The pattern of S waves is as shown in the diagram with a shadow zone, with an S shadow zone. The S shadow zone is beyond 103, 105 degrees. Yes. वो प्रॉपर्टी है. Properties में we don't ask questions why. Okay, why does water boil at 100 degrees centigrade? That's the property. Why does gold look yellow? That's the property. हाँ, P का वो property है. P waves can enter even a liquid medium. So properties में we don't ask why. Remember this. That's how it is. Okay, metals will shine. Why? That's the property. So P waves का nature ही है that it can pass through fluids, S waves can't. And when they pass, the velocities will change in some ways. Yes? नहीं, you're right. यहाँ पर assume कर रहे हैं कि अभी पूरा solid है. Understand यार, हम लोग, we are not doing geological details. Geology details में अगर यहाँ पर magma आ गया, यहाँ पर convection cell आ गया, yes, they all will get disrupted. Okay, I'm assuming it's solid, and that's how they behave. In reality, I'm sure it's far more complex in what we are simplifying. Yes, Suraj, something of that kind. Okay, fine. I think we'll stop here today. Three things. Number one, you have your submissions on assignments next week. You online students. One. And number two, the older students, जिसका नाम हमने बताया था आप लोगों को, stay back for the class at 3 o'clock. Others can leave. And number three, we don't have a class tomorrow, Sunday, and also on Monday this time. Because Monday I have an appointment of a meeting I have to go. I'll resume from Tuesday, all of you. ठीक है? So 2 days extra मिलेगा आपको, Sunday and Monday. Finish all your synopsis work and your current affairs, whatever you have. दे दीजिए. And those who want to submit a synopsis of the peer assignments, do it now. नाम लिखा है? Okay, thank you. बेटा इसमें ना आप लिखो Geography Foundation and mention the batch, July, June, जो भी है batch. Settlements. Where's your name? हाँ तो लिखो यहाँ पर Geography Foundation और batch लिखो. Not now, Muskan. I'll let you know. I'll let you know. Bye. Anybody else? Submissions? Batch likho. Geography Foundation and the month. Density is कोई चीज में कितना मैटर है, कितना पैकिंग है. Rigidity is कितना हार्ड है.
होगा वो हार्ड
नहीं, not necessarily.
सर वो सेटलमेंट ज्योग्राफी की ऑनलाइन लिंक बंद हो गई है.
अच्छा, I will activate it.
सर एक बार
ठीक है, not necessarily.
सर एक बार मूवमेंट ऑफ बिल्डिंग बता दीजिए उसमें पी वेव में.
क्या जानना है बहुत बताओ. What are you missing?
इसके अंदर एल वेव्स में आपने बोला आप
एल वेव्स में साइड बाय साइड हो, स्वे होता है. हाँ,
और एस वेव में अप एंड डाउन.
नहीं, एस वेव्स जो है दो तरह का होता है. अप एंड डाउन भी हो सकता है, ऐसे भी हो